Students, good evening. Students who are in the online. Am I audible to you? Fine. So let us move to the further. So the continuation of the operators. Bitwise operators. Come in, ma'am. So I'll go to the next. Monica, I already taught to you, ma, that doubt I have seen it already. So that doubt is already explained in the last class, no, ma. So this doubt is very simple. Go to the command prompt. Observe now. This is a points we have. R and then this is 20. What is the answer now? Come on, fast. So here, the thing is, try to look
Recording
into
in
this.
progress.
First, I told what, or under operator is there. First, you see this and observe this. Both of you need to evaluate. So 100 and 300 is what? 300 is an answer. 300 and then what? 100 minus 1. What is an answer? Minus 100. And if I take out that sentence once again, that result 100 or minus 100 or what? 20. Come in. So what is an answer now? 100 or 20. This is an answer. Okay, ma Monica. So 100 is an answer. Now, let us move to the further. Next important concept is there. I'm going to discuss. Bitwise operators I'm going to discuss now. Very important, students. So let's follow bitwise operators. Who knows C language here? Girls, even I say good evening, also not saying good evening. Good evening. So, even I said good evening, also you are not saying good evening. So that much busy. Do you know C language? Don't know. Only Python knows. Okay. Boys, who knows bitwise operators? Who knows C language? Don't know. You know, but you forget. Correct. So, option A, don't know. Option B, no, but forget. Option C, completely don't know. Option D, no? None. Okay, none. So none is not there. Option C. Okay, C, raise the hands. How many? C, because I'm not going to ask any questions, only C. Okay. Okay, correct. Next. A, B. A na B na? B, very good. Sincere student. Raise the hands. B. No problem. I'm not going to ask any questions. Okay, good. A, option A. Option A. So I did not see these options so far. No problem, students. So I know that part only I'm expecting. Answer B I expected. No issue. But after I explain, don't try to forget. So it's my advice. Don't try to forget. So let's start the discussion now. We are going to see that I'll explain from the bottom of the subject completely in the entire class. I'll explain bitwise operators only. Try to follow. So this is 16th. This is 16th. 16th Sunday now? Sunday, right? 16th Sunday. 7 a.m. to 9 a.m. A workshop on problem solving approaches. Problem solving approaches. Session number 1 will start. So this will be continued for session number 365 also will be continued. Continuously my sessions will be continued. Problem solving approaches are going on continuing. Session number 1 I am going to start. So as long as course is going on continuing, try to attain. Any of your friends are there, you give that link to your friends also. Keep that link in your Google Drive class. And that is because I'm announcing this for all the batches, for all my batches, all 5 batches. That link is up to 1,000 students only allowed. Only first 1,000 allowed. Relaxly, if you wake up at 7:30, if you try to click on that Google Drive link, you will not be joined. The 1,000 capacity means what? You know, if you take it, each students, if you take it, here 278 students are there. Slowly they will join after that. 340 students, they will be here. And almost 150 students here. You only become almost what? 450 like that. And half students you remove. Why? Sunday sleeping is important. So at least 200 students will join or not. Like that if I take, and you will send the same link to your friend also. Your friend is more interested than you. Your friend is more interested than you. Friend will join more faster. And like that, people will join within no minute. Like 6:10 will start standard time. Sunday 7:10 I will start the session. Okay now? So by 7:10 you must be in the class. Okay? So take care students. I'll post that link. Vivek will join at 6:59 AM only. Okay. Very nice student. So we'll be keeping the link in tomorrow evening or Thursday morning sessions I'll keep so that you can join in that. Okay, students? And it is not one session, continuous sessions this is. Suppose I'm solving the problem solving approaches on list, for example, tuple, dictionary. What are the various problems coming in the industry? And the next is called what? Like that, every topic problem solving approaches. Problem solving approaches gives you what? Intelligence in writing the coding. That is what is called Python. Python is required. So even I want to add the slogan to that problem solving approaches using Python in the bracket. What more? Discussion going on. Anybody talks in my class, I'll send you out of the class. Both of you become friends again. Both of you. No, not friends. When not friends, then why to talk more? Don't disturb the class. So now I'll be talking. That's what I said. Problem solving approaches using Python. A success route to the Pythonist. And there I'm going to talk so many number of topics, including data structure related topics also I'll explain. Stacks, queues, linked list, DQs, binary trees. And which session it will come, I don't know. But sessions are going on: session 1, session 2, session 3, session 365, session 400, those things. No recording will be given. You have to attend the session completely because it's a free for all. It's a free for all. We are going to discuss. Okay now? So I said the importance. Let me go for the session. Because I conducted Java in 3-4 years. And 3 to 4 years I carried that sessions. Almost I carried Java 308 sessions I conducted. That sessions is very helpful to the people who knows Java programming already. And these are all called what? Hacker ranking kind of examples we'll be discussing. Data structure related things. And most different things than our classroom examples. So that's why students, don't miss the concept. Shall we start off? Okay. Now look at that. Purpose I'll write after 2 minutes. I'll write after 2 minutes, first line I will fill it up. So I'm writing here the bitwise operators. The bitwise operators are applicable on which data? Integer data only. Integer data only. But not on floating point values. floating point values, but not on floating point values. Bitwise operators are applicable on integer data only, but not applicable on floating point values. Sir, why? Because I'm going to give you the reason. Because integer values contains a certainty. Certainty will be there. Some certainty will be there. Whereas floating point values does not contain certainty. I'll explain the meaning of that. Let me come to students. Integer values contains a certainty and floating point values does not contain what? Certainty. Let us go to the Python command prompt, students. All of you students. A is equal to 10. You see guys, print of A, it print 10 only. Print of, I'm going to say percentage F, 0.F, percent of A, which contains what? 10 is 10 only will be printed. 10 is 10 only will be printed. I mean percentage of 10 point after that what? 6 zeros printed. Even after that data 25 I am saying. It is also printed what? 10.000 only printed. So it never loses its integrity. It never loses its correctness. I'll say 75 also. It never loses its integrity. 10 is 10 only. Okay. Now A is equal to something like 3.4. When I say 3 point print of what? A, 3.4 is printed. Generally people will think what? 3.4 is 3.4 only they will think. But in reality, 3.4 is not 3.4, my dear students. You see 3.25A. If anybody a small problem either in this projector, students, try to use the right side projector. If any blur if you feel, you try to use this projector, because tomorrow I will make it to rectify. So this, see this now. After the dot, I'm printing 25 decimals. See that what is happening. It is printed as what? 3.4 is not 3.4 always. It is going to contain what? 3.39999, etc. What is this indicates? Is it certain or uncertain? Uncertainty is there. You go for 0 point something like 50, you say. 50, you say. Still it is printing what? Some more number of values are printed. This is up to 80. Still there are so many number of digits are there. Is it float contain certainty or uncertainty? So bitwise operators are applicable only on integer data, but not on floating point values. They will ask you the question, why this happens? You have to answer it. Bitwise operators applicable on certain values, not on uncertainty values. Did you understand, students? Now, I'll move to the further, students. I'll move to the further now. What is my point here is, it's very simple like. Now, how these bitwise operators, what is the bitwise, why they named as bitwise operators? The execution process of which operators? Bitwise operators is that first given integer data converted into which type? Converted into which type? Binary data. Do you know how to convert into binary data? Did I explain this? And programmatically also you know, na? What is the function used for it? Very good. Bin of, and you'll pass the integer data. So it is converted into what? Binary. Very good. So except the execution process of bitwise operators is that first given integer data converted into what? Binary data, and or depends on bitwise operator type. Bitwise operator type. Operation will be depends on bitwise operator type, comma, operations performed on binary data in the form of what? Bit by bit. In the form of bit by bit. So indirectly I'm telling that all the bitwise operators converts the given integer data into what format? Binary data. And operation will be carried on binary data in the form of bit by bit. Depends on which operator? Bitwise operator. Are you following me? So here I am writing here. I will cut this part and I will add in the last. And operations performed on binary data in the form of bit by bit depends on type of bitwise operator. And hence, I say, and hence, these operators are named as, what operators? Bitwise operators. The name itself, now you understand bitwise. Bit by bit operations will be carry forwarded. That's why they named as which operator, students? Bitwise operators. So what is the use of bitwise operators now? There are a lot of examples I'll tell you. The purpose of bitwise operators, is that to perform operations on what? Binary data in the form of what? Bit by bit. How these operations will be done? I am going to show the things. The purpose of bitwise operators is that to perform operations on binary data in the form of what? Bit by bit. In the form of bit by bit. Now I am going to write it. What are the various values are available here? Now we are going to discuss. Shall I start up? Now coming to the point back. Now I'm going to say, coming to the point back. In Python programming, we have 6 types of which operators? Bitwise operators. 6 types of bitwise operators. They are, number 1, I am talking about bitwise left shift operator. Bitwise left shift operator. So the symbol for that is called what? Like this. Like this I am going to say. Second one I am going to take it. Bitwise right shift operator. I'll explain separately each and everything. Bitwise what operator this is? Right shift operator. The arrow you see, arrow towards right side, towards left side. Are you able to get it? Next is I'm going to take up. Third one I'm going to take up. Bitwise. Next one is called OR operator. Bitwise OR operator. Symbol is called vertical slash. Fourth one is called what? Bitwise AND operator. Bitwise AND operator. This is called something like this. Fine. Single ampersand it is. So fifth one is called what? Bitwise complement operator. Bitwise complement operator. I'll use the symbol called tilde under the tilde. Sixth one is called what? Bitwise XOR operator. Bitwise XOR operator. It is going to have something like this. These are called what? In Python programming, we have 6 types of bitwise operators. Number 1, bitwise left shift operator, bitwise right shift operator, bitwise OR operator, bitwise AND operator, bitwise complement operator, bitwise XOR operator. Now I am going to discuss each of these operators in detail. Shall we start up? Now I am going to talk about bitwise left shift operator. I will explain. So let me go for students. I will explain separately bitwise left shift operator. I'm not explaining all of them one line only like earlier. I'll explain separately, students, because I give more preference for this first. Because in written test, you write anywhere compulsory question. 2 questions compulsory will come. And any student you take it, of course, don't feel that I'm boosting. If you read your notes very well, you will answer. Otherwise, you also cannot answer. Like others also, we will be equal to. So, but my responsibility, I'll give full length explanation students and you can almost understand perfectly. Now, so coming to the point of it, bitwise left shift operator, I'm going to deal with this. What exactly? Syntax I'll go, and then I'll go for the explanation, examples and everything I'm going to discuss. So let me go for what? First, syntax I will take it. So syntax we will go for it. So coming to the point of it. So he is asking, Ram is asking, can we call bitwise complement operator as bitwise not operator? So, my dear student, because I don't want to add my own spicy to the subject, what is given in the PSF documentation, that only we need to discuss. Because I'm not a brother of Rosam or somebody else. I want to tell you the subject as it is. Like other faculties, I don't want to add my own spicy to that. Bitwise complement operator, maybe Ram is getting somewhere else. Bitwise not operator, they are saying. Bitwise not operator. What is not operator, ma? Opposite result will come or not? Here opposite result will not be coming at all. That's why don't add your own spicy. Don't ask your personal doubts regarding that. So coming to the point of it. So Ram, my lecturers start bitwise not, sir. My lecturers taught bitwise not, sir. I did not understand your English, my dear student. Try to understand the further. I did not understand your English, my dear student. So I want to go for, leave it. Try to learn from me. Whether they taught or not, I don't know. But try to coming to the point back. So I don't know about whether they taught to you or not, but I want to teach you. Try to learn perfectly in the class. Now I'm going for what? Bitwise left shift operator. So further I'm going to take up a small bitwise left shift operator. Small awareness I want to bring to you. So small awareness I want to bring to you. Already I was applied bitwise operators previously in the case of what? Set operations. Did you remember? Intersection, union, those places I already applied what? Bitwise. So those things I will explain. Certain things I will tell you the working functionality in the class. So let me bring to the note awareness about the bitwise left shift and right shift. For example, this is a class is going on. This is a classroom, for example. Here there are some chairs are kept. So at a time, 5 chairs are available. At any point of time, 5 students will be filled here. So 5 students are sitting here. 5 students are listening the class. 5 students are available and sitting in the class. For every half an hour, students will change based on first come, first served. Because for every half an hour, topics will be repeated. Some formulas will be repeated. For example, 30 formulas are there. So one student may attend from 1 to, one student may attend from 10 to, one student may attend from where? Some 6 to all formulas. So even though it is reaching to 30, again first formula will be taught or not. So that 6th student who started attending, he will attend up to 5th. When 6th comes, he will leave. Correct? So let us assume that this is the 5 students are there. And after half an hour, some students are ready here. Here, for example, 3 students are available. 3 students ready to attend after half an hour. These the first he came. Later they joined like this. Later this is an order of their joining. Class is going on. Half an hour is over. Who is supposed to shift out? Who is supposed to shift out? Come on. 1. After that, next after that, 3. Why only 3? Because how many are waiting? How many students are supposed to shift? This 1, 2, 3 are supposed to be flipped off. Flipping off means what? Removing from that place. And so these students who are sitting here will be shifted to the last chair or not? These will be coming. These new students will be placed from where? 3, 4, 5 onwards will be placed. Are you getting? What is this process is called? Shifting left side. Shifting what? So that type of applications where we can use in very shortly in further that will come. So today I am telling about bitwise left shift operator functionality, students. Let me go to the very serious example. Try to take care carefully here. Now I am going to take up something like this. Observe now. This is what operator I am discussing. Bitwise left shift operator I am going to discuss. So here I am going to talk about something like this. Try to follow me easily. This operator is containing something like this. What I'm saying, look at that. N is equal to, example I am starting with, N is equal to what? 10. Or A is equal to 10. What is this? A is equal to 10 is a given number. The moment when the given number is taken, the moment when you apply the bitwise operator, the given number is converted into what format? Binary format. RES is equal to, some R is equal to, I can say, A, right, left shift operator. There is a left shift operator. Number of bits which I am moving is called, for example, 3. 3. Number of bits moving is called what? 3. What is this meaning? I am going to explain one by one carefully. Because the first operator, I need to explain very carefully. What is the binary format of 10? Quickly tell me. 1010 or not? Binary format of 10. If you don't know binary conversion, I already told you in the class. So 0. And what is this now? 1. And next is called what? 2 1. This is called what? 0. What is an answer now? 1010. 1010 is an answer for what? 10. Now coming to the point of it. How many bits are there? 4. Do you feel that only 4 bits will be coming or more than 4 also will come? Come on. Suppose 16 you take it. 16 you take it. What is this now? 2 6 2 8 What is this? 0. Next is called what? 2 4 0. Next is what? 2 2 What is this? 0. Next is what? 2 1 0. How many? So 0 0 0 0 and then what? 1. How many bits here? 4. Any bits representation you are taking, they started with 4 bits storing minimum. And this 1 is also there or not? In one binary format, 4 bits will be starting with. That is called beginning of the information technology. They stored this data with a 4-bit register. What register? But 4-bit register is not suitable to store more than 4 bits. What is coming here? 1 is also came. So additionally, what will be placed here? 3 zeros will be added. This also going to become what? 4 more bits. This is called what? 8-bit register we can call. Spell out. 8-bit register. Do you get the number more than 8-bit also? Compulsory will come. Definitely, for example, 1 is coming here. What you will add once again here? 0 0 0 will come. But this will 0 0 1 will come. Once 4 will become 8, 8 will become what? 4 becomes double. 8 will become what? Double. What is that now? 16-bit. 16 will become double. What is that? 32. 32 will become what? 64. Now it is called what? 64-bit register, 32-bit register, 8-bit register, like that our computer storage starts with. Your laptop is 32-bit and then 64-bit. Are you getting that words now? That means this type of representation only where we are going to use for data storing. Now I am going to say, students, I want to represent the value of this A, something like this. Follow me carefully. Follow me carefully. Now I am going to take up value like this. What is this value says here? I am saying, carefully follow, students. Now I am taking here. I am taking there 0. I am taking. Next I am going to take it 0 here. 0 here. Next I am going to take it here 0 here. 0 here. 0 I am taking. Next I am going to take it what do you know? I am going to take it 1 0 1 0 and next is called what? 1 0. Are you able to follow? So here I am trying to write, students, carefully follow and don't need not to be hurry at all. So I'm going to say this values I'm taking like this. So zeros you take it, and here I'm taking 10 like this I'm taking. This is my given data. What is this is called now? Come on, what register it is? 16-bit. You can take 8-bit also. 12th bit, 12 bits it will not be there. Don't extend 4, 8, 12 like that. 4 will become what? 8. 8 will become what? So A is equal to 10. A is equal to 10 on which bit register? 16-bit register. I will explain slowly. Try to get me. 16-bit register. Now, after that, now A double less than 3. What is the meaning of this? What is the meaning of that? The name itself says left shift. What is the meaning of arrow itself? You recognize this arrow itself. Which direction is moving, left or right? That's why they named as which operator? Left shift says what? How many bits will be flipped off? Flipped off means removed. How many will be removed? 3 will be removed. And once 3 will be removed, is it coming to the last or not? These things will be having what? Corresponding moment towards which side? Left side. Everything will be coming towards left side. Can I write that? Now I'm going to write it, students. Carefully try to follow. Now I'm going to take up the same diagram I'm going to carry here. The same diagram I will carry here. Now see that. I'm going to write it. This also I will try to shift to little down because I don't want to make it too much hurry here. Try to understand first. So because of the statement, what is happening? Because of the statement, what is happening? Come on, fast. These 3 bits will be moving towards which side? Left side. Towards which side it is flipping? Left side. This is towards left side, it is flipping. So this is all flipping towards left side. Once these are flipping towards left side, flipping is nothing but almost removal only. Once they are moving towards left side, automatically other bits will be moving to left side or not? Once they move left side, right side, how many things will become vacant? Come on. 3 things will become vacant. Correct or not? So I'm going to ask you further one more diagram I am saying, student. Try to understand now. I will take this diagram, guys. Same thing I will take it. Once again, I will carry this. Now I will paste it. Here I am going to write it. Here I am going to take up. What is this R is going to contain? What is this R is going to contain? If you remember me, these values what we are having, these 3 values are removed and these 3 values also removed. Now I will write properly now. If you follow me, what this becomes? If you understand 1, 0, 1 and the next what? Come on, 0. This will become 0. And here what will be there? Underscore, underscore, underscore. What is this underscore, ma? Is it empty or not? Empty. Empty means what? Nothing is there inside. Your PVM will place what values there, students, you know? Your PVM will place what values, you know? Zeros will be placed. Which one will be placed? Zeros. Zeros adding to zeros is nothing but no value at all. So tell me now, what is this is becoming now? Are you understanding the shifting of this side now? Everything is moving just one bit towards left side. When I move 1 bit towards left side, last 3 things will become what? Spaces. That spaces will be containing what? 0. Now tell me, what is this value? Convert into what? When I print R, it is supposed to print the data in the form of decimal number system or not? What is this value, please? 2 to the power of 0, 2 to the power of 1, 2 square, 2 cube, 2 cube, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, right or not? And all these things is called 2 to the power of zeros only. Tell me 1 into 2 to the power of 6, how much? Mathematics problem. 2 into 2 into 2 into 2, how much students? 16. Into 2, how much? 32. Kada? 32 into 2, how much? 64. 64 is the value. 0 into 2 cube is called 0. 1 into 2 to the power of 4 is called what? 16. Others are becoming 0 only now. What is the answer now? 80. Are you following? 80. Now I will write it here. Result is equal to, what is that? 80. Now I will print student. I'll print here. What is this now? Print of R. Print of R. What is the value printed? 80. Now ultimately I am going to conclude my sentences. Ultimately I am going to conclude my sentences. I am going to say, what is this now? 80 is the result. Now, when they ask in interview point of view, face-to-face round, how this will work out, you have to take. Let us consider 16-bit register. Can I represent it in 32-bit register? Yes. I can become, these are all becoming zeros only, just a double, everything becomes 0. And I'm moving how many bits left side? 3. Whether it is 32 or 16 or 8 or 32 or 64 or whatever it is, 3 flipped off towards left. Are you going to enter into that? So, how 64 become 80? Can you explain please step again? Already I told that thing in the binary conversion to what? Decimal, binary to decimal already explained. So my dear student, 64 plus what is this is becoming 2 to the power of 5. This is becoming 4. 2 to the power of 4 is nothing but what? 16. 84 plus 16 how much? 80. So I'm adding that. Already this is explained in the beginning only. That's what I'm saying. Not understanding reason is not reading the notes. If you read the notes, no problems will come. Now I am explaining the formula today. Now I am explaining the formula. If you go for writing written test, how to answer it so quickly. Let us go to the Python environment now. A is equal to 10. R is equal to what? A double less than what? 3. A double less than 3. Print of what here? What is an answer? 80. Do you know formula? I am writing formula for shortcut formula. And if you go to the entrance, some shortcut formulas will be there or not? Formula for which operator? Right shift, left shift operator. Formula for left shift operator, I am going to tell you. Formula for left shift operator, I am going to tell you. Try to look at students. Formula for by the left shift operator, I am going to explain. So let us watch this now. I'm going to give you the conclusion. Formula for left shift operator. I'm going to enter into this place. So see students, I'm going to write it. Here I'm writing. What is that? Saying, I'm taking that result is equal to given number into, I'm writing number of bits I'm saying. Number of bits. This is called what? Formula like. It's like a syntax like. Even I can write under syntax. Under syntax, I'll write it. What is the syntax here? Variable name is equal to this formula. You take it. You take the same thing. Under this also, I want to write it. This is called a syntax. Left side, I'll write variable name. Variable name, I wrote it, is equal to. Come on now. What is the formula for this? Shortcut. Result is equal to, what is that? I'm going to say, Naveen Kumar, try to, you don't know and you are not going to happening something, right? That's what I'm saying. Given number into 2 to the power of, given number into 2 to the power of number of bits. Unnecessarily don't waste your time. And is it correct? No. I told already, whatever you say, that is a wrong. I told already in the class. Why you want to test by yourself, ma? So 2 into what? Into what? The given number into 2 to the power of number of bits. Example you carry. So here I am going to say examples I am going to carry. See this example. What is the given number? Say this now. Again, Gauss is saying this thing. So Gauss is saying that let me take all these blunder things in the class. Is a blunder. And one more thing, because by seeing that my students are answering like that, I want to go for giving blunder. And blunder will become a thunder in your career. Now coming to the point of it. These are all called blunders. Now, let me come to the R is equal to, what is my R is equal to? R is equal to 10 given number double less than what? 3. What is the formula I told ma? R is equal to, what is the given number? Into what? 2 to the power of 3. 2 to the power of 3. 2 to the power of 3 is nothing but what? So you are supposed to write 10 into 2 star 3, right or not? 2 star 3 is called what? Exponentiation. As Gauss has written 2 cap 3. Because I told already, outside people will say like this only. This is called what operator? Exclusive OR operator. That is a blunder first. So they may feel, but being a student of mine, if they say wrong thing, I want to give left and right first. So that is a blunder first of all. Now coming to the point of it, that's what Gauss. That is not a 2 to the power of 2. I will write it. You just look at, again you are covering your answers, print off. Of course, your personal thing, you feel it whatever you like. 2 to the power of 3, you write it. And still you are going to say the same thing to me. 2 to the power of 3, what is the answer? See that? You wrote 2 to the 2 power, you wrote it. Is it 2 power? The blunder I said. Again you say 2 to the power of, what is this working? This is what people says outside. What is that 2 binary? 0, 0, 1, 0. And what is this now? 0, 1, 1. I will tell you the answer for that. This is exclusive OR operator. What is the exclusive OR operator? Similar bits are 0. Non-similar bits are what? 1. I will explain that. 0, 1 will become 1. 1, 1 will become 0, 0, 0. What is the answer? 2 to the power of 0. 1 into 2 to the power of 0 is called what? 1. This is the subject. Suppose if from somebody write as Gauss written, you follow outside, but in my class, no wrong should be done. 3 to the power of 4. You don't think that 3 to the power of 4. He wrote that only. See, I wrote 2 to the power of. You see his chart window. No student of mine should write wrong. 3 to the power of 4. He is thinking that 3 into 3, 3 into 3, 3 into 3. 3 into 3 is 9. 9 into 9 is called 81. He is thinking. But what is this answer you see? 0, 0, 1, 1, 0, 1, 0, 0. What is an answer now? 1, 1, 1, 0, which is equal to 7. That is 2 to the power of 0, 2 to the power of 1, 2 square. 1 into 2 square, 4. 1 into 2 to the power of 1, 2. 1 into 2 to the power of 1 is called 1, which is an answer is 7. So 3 to the power of 4. He is thinking 3 to the power of 4. I am saying that it is a blunder. What is an answer? 7 you see. You test it wherever you like. Java also you tested. C language also you tested. Who invented that wrong things to the minds of the students? I don't know. That's why student is going wrong. If this question is coming in interview, first question they will give you what? 81. Will you select 81 or not? Gauss, please realize by yourself. I hope you are realized it. If you realize, you say realized. Otherwise, don't reply anything. You don't reply anything. That you say anything. I will watch your chart window. If you realized, you say realized. Otherwise, go for that. So, coming to the point of it. Right? You say realized. Otherwise, don't reply anything. R is equal to what? Wrong is wrong. That's all. 10 into 2 cube. What is the answer now? 10 into what? 8. That is equal to what? That's all. This is an answer for the formula. Are you able to follow? That's all. So go to the point back. Now I am going to answer it. Answer my question quickly now. 20 double less than 2. Answer please. Answer. 20 into what? 2 square. 20 into what? 4. What is an answer now? Come on. 80. Are you following? Yes. Now, coming to the point of it, one more student is asking, see that Injamami is asking this type of question. So, Injamami is asking this question. See students, how the doubts will come. Please explain, how did you take 2 to the power of 4? Star star operator meaning. I did not explain now. Did I say 2 to the power of 4? What is the value I actually having? That these are all called what? Severe problems in your career. This is 0, 0, 0, 2 to the power of 0, 2 square, 2 cube, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. Where I was explained it in the beginning days only, integer conversion time only explained this. So the 1 into 2 is 64, plus 2 to the power of 5 is 0, and 2 to the power of 4 is 16. Rest of them are called zeros. So this is called what? 80. So this I was explained in the beginning only because they think that this is not explained. Data types, fundamental data types, conversions, decimal to binary, binary to decimal, there is a formula. You see that it is available. Already explained this concept. Already explained so detailedly. So again and again explaining is so much problem here. Are you able to follow? So done. Go to the place. Now this formula, I hope it is clear. Just try to remove and I hope, coming to the point of it. What is now 20 into what? 2 to 2 square. 20 into what? 4 is called what? 80. If I don't respond to the wrong answer, students, they will think that it is a correct. Same thing they will say in interview also. Unfortunately, they are losing the opportunity. If I react on their doubt so seriously, at least they will change it if they want to learn subject. Otherwise, still they will cover by themselves. Still they want to compromise by themselves. We are helpless. Nothing to do with them. Are you following me? Right. Next I am going to see. Now I am going to say 25 double less than something like, 3 I am writing it. What is an answer now? Come on, answer now. 25 into what? 2 cube. 2 cube. 25 into what? 8. What is an answer? Come on. 200 is an answer. So will you answer such questions are coming? Right. Are you able to follow? Yes. So this is the way how you can take up this type of values. Okay now? So did you understand this left shift operator? What is the syntax I wrote it? Let us watch this left shift operator once again the diagram now. In this case, in the left shift operator, we are moving the number of bits towards what? Depends on the number of bits. We are moving the number of bits towards left side or not. When I move number of bits towards left side, right side will become some vacant or not. That vacant place we are adding what? Zeros. How many zeros? How many number of bits I am moving? That many number of zeros only will be added. This is comes under what? Left shift operator. So go to the place. Now I will bring that left shift operator, students. I'll get it operators here. Under that bitwise operator, I want to get it. What is that? First, I want to take it. Bitwise left shift operator, I want to bring it. Bitwise left shift operator, I just want to bring it. So carefully follow, students. Now I'm going to bring to this place also. Your place also, I want to bring it. In that place, separately, I want to create one small folder. Why? Because I give more preference for bitwise. Because when you go to an interview point of view, this is a compulsory questions. Provided if you read my notes. If you read our already some notes and then getting problem, power, etc., all these things, helpless, we cannot do anything else. So let us coming to the point back. Read out this concept now. Variable name is equal to given number double less than number of bits. What is the concept? The bitwise left shift operator shifts number of bits towards left side by adding number of zeros at right side. How many zeros? Depends on number of bits. So that result will be displayed in the form of decimal number system. Already I told you, na? What is that? Even though I represent binary data, octal data, hexadecimal data, it is coming in the form of what? Decimal number system. Example, A3, B3 and A double less than B, 10 double less than 3, 100 double less than 2. All these things coming or not? This is called what? I will add this type of parts also to your example. I hope that you are understanding these parts. Understand, students? Now, shall I move to the next one? In further, where I will use this operator in my application development, I will tell you. Where I will use this operator in my application development, I'll explain clearly. This is today you understand about this operator, how it is working, you understood. In further, I'll tell you in which application we are applying this. Okay. Similarly, same kind of mechanism will be carry forward to which side? Right shift operator also I will take it. Shall I take right shift operator? So see that this is, I will save it bitwise. Which operator? Left shift. I'll go to this place, D colon 6 p.m. What is that now? Operators, nodes, under that bitwise operators, I will add here bitwise left shift operator. Left shift operator. Diagram. DIA. That is operator is done. Same diagram will be coming to what? Towards left side. Can I take it directly now? Now, instead of drawing the diagram once again and everything, I will take it same concept. Which one I will take? Right shift operator, I will take it. Left shift operator, right shift, I will take it. See that directly I will write the example. A is equal to what here? 10. And what is this? R is equal to, come on, 10 double greater than what? 3. Which shift operator it is? See the symbol. Is it left shift or right shift? How the diagram is represented here? How the diagram is represented? 0, 0, 0, 0. What is next? 0, 0, 0, 0. 0, 0, 0, 0. And next is what? 1, 0, 1, 0. 1, 0, 1, 0. And how many bits you are moving towards right? So when 3 bits are moving towards left, what will be happening? Is it moving towards right or not? What the diagram will become, students? Tell me. So this will become what? 1, 0, 0, 0, 0, 0, 0, 0. And next is what? 0, 0, 0, 0. And I will take it here 0. And here what? Blanks. In that blank places, what I will insert? 0. Moving number of bits towards which side? Right side. By adding number of bits towards left side or not? And what is the result now? 2 to the power of 0, 2 to the power of 1, 2 square, 2 cube. You write any number of thing. 0 into all these things will become 0 only now. Plus 1 into 2 to the power of 0. Answer is 0 plus 1 is called 1. Are you following me? Getting up? And see that once again, A is equal to 10. And I am writing R is equal to what? A right side of 3. Print of R. What is an answer now? 1. Getting the diagram now? Formula I will tell you. And how to answer it quickly in interviews. How to answer it. Simple, students. Very simple. What is my given number? 10. What is my number of bits? So the formula is given number by what? 2 to the power of number of bits. 2 to the power of number of bits. It is the division I am applying. What is the given number? 10 by what? 2 to the power of 3. What is the answer now? 10 by what? 8. 10 by 8. It will not give the result in the form of decimals. Because decimal value is nothing but floating point values. Binary operators will not work on floating point values, working only on integer. So it is going to apply this slash operator, not a single slash. You have to apply what? A double slash. 10 double slash 8 will give you what? 10 of what? 8. 8 1 ja 8. What is the answer now? 2. 2. If I start here, normally I am doing 8 2 ja what? 16. What is this now? 4. 8 5 ja what? 40. Remainder is called what? 0. But double slash will give you what? Answer is 1 only. Single slash if you apply, it will give you what? 1.25. But 1.25 is answer no. What is an answer now? 1. Apply now. Quickly you apply now. Print of what? 10 double greater than 3. Answer is what? 1. One more answer I am asking. One more question. 25 double greater than 2. Answer please. What is this shift operator? Come on. Right shift. Right shift formula is what? 25 by 2 square. 25 by what? 4. 25 by single slash 4 or 25 by double slash or? What is an answer now? 6 is an answer. 6 is an answer. 6.25 is not an answer. Take care. What is an answer now? 6. Are you able to follow? One more answer. One more answer. 100 double greater than what? 4. Answer please. Multiplication problem, kada? 100 by what? 2 to the power of 4. 100 by 16. 16, 6. Answer. 96. Answer is what? 6 is an answer. 6 is an answer. Are you following? Very regularly asking questions these are. Now I am going to apply right shift operator. I am going to show you. Try to read out that right shift operator. Come on, everybody. Bitwise right shift operator. Variable name is equal to given number double greater than number of bits. The bitwise right shift operator shifts number of bits towards right side by adding number of zeros at left side, so that 1 minute more, so that result will be coming in the form of what? So here it is something cut, maybe there, I hope so. Okay, it's there. So that result will be displayed in the form of what? Decimal number system. A10, B3, A double greater than B. Answer is what? 1. 10 double greater than 2, 10 by 4. Answer is 2. 25 double greater than 4, 25 by 16. Answer is 1. 24 double greater than 3, 24 by 2 cube 8. 24 by 8 is called 3. 50 double greater than 4, 50 by 16. 16, 3 is 3. 45 by 2, 45 by 2 square, 4. 45 by, what is that? 4. 4 11s, 44. 11 is an answer. Understood? This is very, very simple, students. This is which operator? Right shift operator. Let me show you diagrammatic format also for you. Diagrammatic format also I will show you. What is this operator now? Bitwise right shift operator. Bitwise right shift operator, I will bring it. Bitwise right shift operator, I will bring it. Try to follow me. I'll take operators here. And here I am going to take it. Here I am going to take it. Right shift operator diagram uses. Same diagram like previous I wrote it. Come on, watch it. What is the syntax here? Instead of writing and wasting my time. Given number double greater than what is this? Number of bits. A10 16-bit register, 4 zeros, 4 zeros, 1 0, 1 0. Double greater than 3, flipping of 3 bits, and the answer is this one. Result is 1. Formula, variable name, given number to the power of what? Number of bits. Variable name is equal to given data by what? 2 to the power of number of bits. B is equal to 10 double greater than 3. What is an answer now? B, 10 by 2 cube. 10 by 2 cube is called what? Use double slash. 1 is an answer. I hope you understand this. Students in the online, are you following, students? Students in the online. So I hope you are following my concept. So this is called which operators? How many bitwise operators are there? 6. So can you spell out what are those 6 once again? So bitwise left shift, bitwise right shift, bitwise OR operator, bitwise AND operator, bitwise complement operator, bitwise XOR operator. Don't run the class like a passenger train. Speak out once again. Spell out. Bitwise left shift operator, bitwise right shift operator, bitwise OR operator, bitwise AND, bitwise complement, bitwise XOR. At least when you go outside, what they taught in the class, instead of thinking about like a scientist, you can say today they taught this simultaneously. Quickly they will say, they will understand that you know at least some topic. If you think and then think and then say, they will think that you did not understand. Okay, now I'm going for which operator? Bitwise OR operator I am going to explain. Shall I? Let's start with the bitwise OR operator. See students, take care. Now I am taking bitwise OR operator. Very powerful. Take care. Now I am going to say. Let me go for bitwise operators in the class, OR operator here. And a lot of people, which I observed it, because a lot of careful observation will be there. Bitwise OR operator is something like OR operator, they will say. Both of them will be similar, they will say. Let me show you here the functionality of, now I am going to say, the functionality of bitwise OR operator is completely different from our physical OR operator. Logical operators are there or not? Yesterday only we discussed OR operator. That OR operator, this OR operator, completely different. They are not same. They are not at all same. Now I am going to show you. The functionality of bitwise operator, the functionality of bitwise operator is shown in the following, truth table. Truth table I am going to prepare. Truth table I am going to prepare. What is the truth table? You try to remember. So I am going to prepare the truth table for what operator? OR operator. OR operator I am going to prepare the truth table. Look at that. Here I am taking what will be the operating inputs here. What are the operating inputs here? I told you already yesterday. Physical OR operator is taking what? True and false now. How many combinations I prepared? 4. Bitwise operators operating mechanism is what? Binary bits. How many binary bits are there? 2. What are those? 0, 1. 0, 0, 1 combination. 0, 1 combination. 1, 0 combination. 1, 1 combination. Yesterday false, false 1 combination. True, true 1 combination. False, true 1 combination. And a true, false 1 combination. They will try to say 0, 0 false, 0, 0 false, 0 false, to 1 true. Like that they will say similarity is there. Both of them are same. They will say that's the blunder. Now I am saying carefully follow. What I am taking now? Variable 1 students. Careful all of you. Variable 2. Now I am saying here variable 1 or variable 2. Variable 2. Carefully follow. There I am taking combinations and permutations. So I am taking 0, 1, 1, 0. Come on, tell me the combinations, ma. 0. Next, 0, 0, 0, 0. Next, 1, 1. Very nice. OR operator says theme is same only. Theme is same only. Every businessman theme is what? Getting more profits only. But the doing the business is different or not? Every businessman theme is same only. But the way they are operating is completely different. Answer my question now. VAR1 or what? VAR2. If both the bits are 0, result is 0. If any one of the bit is 1, result is called 1. Once again, if both the bits are 0, result is 0. Any one of the bit is 1, result is 1. Start 0, 1, 1, 1, 0, 0, 0, 0, 1, 1 and 1, 1 or 1. That's all. This is comes under what operator? Bitwise OR operator. Let me take students examples here. Examples I am going to take up. Now I am going to take up here examples. Carefully follow. Now I am going to say, right? Coming to the point, Aniket asking to repeat. What is there, students? OR operator says what? Any one of the bit is 1. Result is 1. Both the bits are 0. Result is what? 0. 0, 1, 1. 1, 0, 1. 0, 0, 0. 1, 1, 1. Aniket. Now coming to the example. Coming to the point back. 0 or what? 0. Answer is what? 0. 0. 0 or 1. 1 or 0. 1. 1 or 1. 1. Aniket. Aniket, coming to the point back. This is called first example. First example. So, coming to the point of it, this is called a truth table related functionality expressed in the form of an example. But this question is very simple. Elementary level this is. Elementary level this is. When you go for an interview, they won't ask ABCDs. Will they ask? But to qualify an interview, ABCDs are compulsory. So coming to the next example, now I'm going to say, Aniket, are you following? Can you respond? Did you follow? Yes, followed. Now I am writing answer. You see, A is equal to 10, B is equal to some 12, and C is equal to what? A or B. A or B. Very frequently asked questions. What is the answer of this 10? 1, 0, 1, 0. I'm not writing 0, 0, 0, 0, 0. That entire story I'm not writing. Are you following me? Only 4 bits I'm taking. What is the 12, ma? 12. If we take 12 here, 2, 3, 2, 6. Anybody don't know? I'm just writing. What is that? 0. 2, 6. 2, 3. What is this now? 0. Next is called what? 2, 1. What is that answer? What is the answer now? 1, 1, 0, 0. What is an operator, ma? OR operator. What is the OR operator says? 0, 0. Start these things discussion now. Are you taking or not? 0, 0. Come on, 0, 0. 1, 0. 0, 1. 1, 1, 1. 1. What is that? 1, 1, 1. 1, 1, 1, 0. 2 to the power of 0. 2 to the power of 1. 2 square, 2 cube. What is the answer now? 8 plus 4 plus 2 plus 0. What is an answer? 14 is an answer. Understand? 14 is an answer. See that 14. Print of what? C. Answer is what? 14. C is equal to A or B. Answer is what? Say. C is equal to what? A or B. What is an answer? 10. 10 is kept in where? C. Answer is what? 10. Is both of them same? They are completely different. If anybody says same, show this difference. Getting my point? Yes. Be careful, students. Their OR is different from logical OR. Logical OR is nothing but bitwise OR. Physical OR is nothing but yesterday's point. I hope you got it. I hope you got it. Now I am going to say quickly one more question. I am going to keep it. One more thing I am saying, students, directly. 4 and 5 or 4, I will take it. 5 or 4, I am taking. 0, 1, 0, 1. 1, 0, 1, correct? 5, correct? 4 is called what? 0, 0. What is an answer now? 1, 0, 1, 0. What is an answer? 5. Are you following? Right. Now say here, what is an answer? 5. Getting? Next, 5 or 4. Answer is what? Come on. 5. And don't say, sir, same now. If you think like that, you are out of order. Now, one more thing. If anybody thought like that, because students will think like that. What is an answer? Come on. 4. ఇంకా వాళ్ళని బాగా చేయాలంటే మన వల్ల కాదు అసలు. వాట్ ఇస్ ద ఆన్సర్ నౌ? 0 0 0 0 1 0 1. Answer is what? 1 0 1 0. Answer is what? 5. So answer is what? 5. 4 or 5? Answer 4. So here only there is a difference, is there or not? But this is going to be what? Same. So is it R is similar to this bitwise OR? Physical OR is not at all equal to what? Logical OR. That is bitwise OR. It is totally different. Okay, students. Now go to the point back. Now I am writing like this, and this is my value. Students in online, I hope you got my discussion now. Is it clear, students? Now I will go for what operator this is? Bitwise OR operator. Are you able to follow, students? So bitwise OR operator, we got it. Bitwise OR operator, we got it. Shall I move forward now? So I'm going to enter into the bitwise OR operator, we got it. So I'll save this now, bitwise OR operator. Bitwise OR operator, I will save it. Save this now. Go to the place, bitwise OR operator saving. Similarly, I will go for what? Bitwise AND operator, I will take it. Bitwise AND operator also I will explain. Easy. Don't take much time. Simple. Bitwise AND operator. Fourth one I am talking. Fourth one. Bitwise what operator? AND operator. What is the symbol? Single ampersand. The functionality of bitwise AND operator. The functionality of bitwise AND operator is shown in the following table. How AND operator earlier works? How it earlier works? In the same manner, that is true and false. This is called what? Zeros and ones. But don't remember that. Don't try to answer. That is different. This is different. Because I shown you logical OR. Bitwise OR is completely different from logical OR. That is a bitwise OR. Now AND operator says what? If both the bits are 1, the result is 1. Any one of the bit is what? 0. It is called what? 0. It is also can be applied as product rule happily. Come on, answer please. Come on. Okay, next answer. Huh? Next answer. Next answer. Okay, good. Good. This is nice. Now I'll go to the example point. Example, I'm going to take it. Examples, I'm going to take it. Observe, students. Now go to this place. Now I'm saying 0 and 1. Answer is what? 1 and 0. 0 and 0. 1 and 1. 1. This is the given data. This is the given data. Go to the place. Here I'm going to say so. Uday, ask loud in MIC also, sir. So coming to the point of it, 1 0. Coming to this sentence. 1 and 1 is called what here? 1. This is called what? Elementary level example. Coming to the next level is like this. Go to the point back. This level of example. A is equal to 10. B is equal to 12. C is equal to what? A ampersand B. Come on, students. Answer my question. What is the 10? 1 0. Come on. 1 0. What is the 12, ma? 1 1 0 0. Good. 1 1 0 0. What is that now? C is equal to operator. Come on. 0. Next. 0 0 1. What is this? Good. This is 2 to the power of 0, 2 to the power of 1, 2 square, 2 cube. 2 cube is called what here? 8. Other things are zeros, right or not? 8 is an answer. 8 is an answer. See, students, print of what? C. 8 is an answer. If I write C is equal to A and B, A and B I am writing. What is an answer, guys? Come on, mom. So, print of what here? C. Answer is what? 12 is an answer. Already you know yesterday. It is completely different or not? Yes, completely different. Now A is equal to 8, B is equal to 6. Now C is equal to what? A ampersand of B. Come on, 8, please. 1, 0, 0, right or not? Then, no? 8 is correct. 8 is correct now. Binary. 6, 0, 1, 1, 0. Now answer. 0, 0, 0, 0. 0. 0, 0, 0 is 0. Very good. So answer is called what here? Print C. Answer is 0. A and B. A and B answer. 6. B and A. 8. Are they same? Completely different. I hope you are understanding about this discussion here. So I'll take up this example. So print of this value. Done. Next, one more example, I will take it. This is the data what we have. Completely different. And this is called what? One more example, I will paste it. Are you following me? Now, I'll come to this area. Now, this is the data. Clear? Now, I will enter into one important point I want to cover. Will you understand? Now, I'll go to bitwise OR operator once. I forget to cover one small, most important point I would like to cover. Most IMP point. IMP points I want to cover. Ready to answer? I want to tell you in the R. The same important point I will cover here also. Here also I want to cover. Carefully follow. Go to the bitwise OR operator. Okay? See, S1 is equal to S1 10, 20, 30. You must listen very carefully. And if you ask in the doubt sessions or explain once again, we cannot. Listen now only. S2 is equal to what? 10, 15, 25. 25. What is this is called? Sets they are called. Sets, no? Right. Go to the place. I'll take up here set. Go to this place, Python command prompt. Set. S2 also I will take it. S2 also I will take it. Done. Print of what? S1. Type of what? S1. Close. Of course. Print of what again? S2. Again S2. Type of S2. Also which type? Set type. See students, S1 dot union of S2. What is that printed now? S3. S3. What is that S3? What is that? All the values combined or not? That is called which type again? Okay. Similarly, coming to the point back, S1 and S2. Now I am applying. S3 is equal to S1 or S2. S1 or S2. I already applied in our Venn diagram concept. Today I said that day, I'll explain in detail I said. Do you remember? Now I am explaining. Ready to understand? And if you don't spell out, you will get confusion and you will come once again to me, sir, explain, because it's not a short concept to explain. There's a lot of processes there. Now only you understand. In the online, offline students, carefully follow. Again, explaining in the online, it will be difficult. Now only I'm explaining, listen carefully. Start the answer now. Start the answer carefully. Everybody, start S1 or what? S2. What is happening? This OR operator, every value of S1 is compared with S2. That is the first stage. Second stage is what? S2 value will be compared with what? S1. In that comparison process, what is happening? We are discussing. How this is working, I want to tell in the class. Start. First, what is the comparison? Starts with S1 values compared with S2. First, which value will be selected by PVM? 10. Whichever element you are selecting, that is considered as a binary bit 1. Whatever you are made a selection, that is selected. That is 1. compared with the first value in the set 2. What is the first value you are selecting? 10. Is it matching? Selected element and then compared element matching? What is that? 1 or what? 1 or what? 1. What is the answer? 1. That means 10 is marked for selection. Are you okay? Next, 10 will be compared with what? 15. Again, I will not explain. Only once I will explain. 15. 15. What is this 15? 1 or is it 15 matching with that? No. What is that will be taken? What is the answer? Again 10 will be taken because OR operator. But 10 is already marked for selection or not? Marked for selection. One more thing. 10 will be compared with what? 1 with what? 0. That is not similar. It is called what? 1. 10 is marked for what? Selection. But that is kept into where? S3. This selection of the element is not kept under list, not kept under tuple. It is kept under where? Set it will be keeping under. Are you following? So what is S3 contains now? S3 contains what, students? 10. So which comparison is over? 10 comparison with every element is over. Did you understand? Next. One more time. Go to which selection? 20. Second time I am repeating. What is the selection called? 1. Come on. 20 with what? What is an operation? 1 or 0. What is that? That is 20 marked for what? Selection. Next 20 with what? 15. What is this 21? What is this now? 0. What is this? 1. 20 marked for selection or not? 20 with what again? 25. What is this answer now? 0. Which is called 1. 20 marked for selection or not? That also will add to what? S3. Already S1 was containing. Now what is added now? 20 is also added. Next coming to where? 30. 30 marked for selection. What is that? 1. Compared with what? 1 or 0? 1 or 0, 0, ma'am. But you said 0, I wrote also 0. 1, correct. So, next, 1 with what again? 15. What is that? What is an answer? 1. That is marked for 30 also selection or not? Now, 1 is what? 1 and then 0 also marked for. That is added to what? S3. What is that S3 already contains now? 10, 20, 30. This is what is over. 10 comparison with what is over? 20 over. S2 over. Now S2 comparison starts with what? Start. What is selecting? 10 with what? What is this now? 1 or 1 is called 1. 10 marked for selection. Come on, next quickly. 1 or what? 0 is 0. 1, 1, 1, 1, 1. Like 1 is called what again? 0, 1, 10. 10 is added to whom? S3. Already S3 contains what? Second time 10 is added, huh? No. It is not added because duplicates not allowed. Next what? 15. 15 what? 1. 1 with 10. 1 or 0? 1. 15 marked for selection. 15 with 20. 1 or 0? 1. 15 with 30. 1 or 0? 1. 15 also added to whom? 25. 1. 1 with 10. 1, 0. 1. 15 with 20. 1 or 0? 1. 25 with 30. 1 or 0? 25 also added to whom? That is the story inside. S3 comma what? Type of S3. Answer is like this. Are you following? So this is the main important selection over there. So go to the point back. I am applying this data here and see this process here. This is a bitwise OR operator is applied for what operation? Union operation. Bitwise OR operator for which operation, student? Union operation. Is it exactly working like union operation or not? Now see my concept now. S is equal to, S1 is equal to, I am taking here Python. Next is called a data science. Data science is my subject. S2 is equal to C comma, C++ comma, DSA, data structures and algorithms. Now here two sets are there. Print of S1, print of S1, type of S1. You see, it is called S2, type of S2. Are you following? Now I am applying S3 is equal to S1 or S2. It's a very regularly asking question. Generally, I said this is applicable on integer data, but this is called which data? String data. Applicable or not applicable? That is an important point or not? How it is over? How it is selected? 10. Python with what? C. Python with what? C++. Python with DSA. 1 with 0, 1 with 0, 1 with 0. What is selected? Python is going to be kept in S3. Similarly, data science with all 1 or 0, 1 or 0, 1 or 0 data science. Next, C with Python 1 0, 1 0, 1 0. C. C++, 1 0, 1 0, C++. DSA 1 0, 1 0, C++. So print what here? S3. Print S3. Is it coming all the subjects or not? This is the important point, students. Are you able to get my points? So this is another section of development. This is called OR operator. OR operator. Now I'm going to take up the same thing on where? Same thing on where? AND operation also I want to take up. Okay, students. Now I will go to, this is called what operator? Which operator, ma'am? I will go to the same thing. Coming to the forward, I will come to this level of answer. What I am applying now? Come on. AND operation I am going to apply. Bitwise on AND operator. Bitwise AND operator. For what operation? Intersection. It's a very regularly asking question, student. Start off. So come out of that. S1 is equal to S2 is equal to, students. Please say what is this now? Say this now. Please follow me. 10. Don't forget the flow, please. What is 10 selection? 1 and 1. What is that? 1. Be careful. Be careful. I will apply one more time. Come on. Next what? Come on. 1 with 0. 0 means what? 15. What is the answer? Come on. 0. Next. 1 with what? 0. What is the answer? 0. 0. Out of that, this will be 0 means this will be considered. If all of them, any one of them is called what? True. That will be marked for what? Selection. That indicates there is a common element. Remember that. This is one iteration over. Second one iteration start. What is the second iteration? 20. Quickly, students. 1 with a 0. What is that? 0. Next, 1 and 0. Next, 1 and 0. Out of this, nothing is marked for selection. Understand, guys? Next, I am going to take it one more thing, students. Come on now. 30 I am talking. 1 and 0. 1, that is 30 and 10. 0. 1 and 0. 1 and what? 0 is called what? 0. That is nothing marked for what? Selection. So what is selected only? That is nothing but an intersected element in S3. So S3 contains what now? That is in the comparison of S1 with S2. S2 with S1, you see? Same thing. You understand, I hope so. 10 and 10, 110. The other kind of numbers are marked for 0 only. 25 with other things marked for nothing only. 10 was only selected. The 10 was added to S3, which was already added in the first phase only. Is the second time 10 is added on? No. Print of S3. Print of S3. What is that? 10. Getting, students? Getting this thing, I am saying this. You say here, I am saying that here something like this, comma, I am saying that Python I will add, for example. Python I will add. What is an answer? Python is an answer. Okay. Add this. Like this, you say, students, print S3. What is an answer? Suppose, for example, this is the data. This is the data. This is my data. Here it is like this. I am applying S3. S3. What is an answer? Empty set. No common elements. Empty set. Empty set coming or not? This is the important mechanism, students. So here I'll take up here. What is that first one? So I got the answer for first one. Where is it? Okay, this part I will carry this example. Here I am going to say S3 is the data here. Now this value is coming. Next I'll go for one more. This values I will take it. Observe now. Got it, this point. S3, in this case, this is like this. Now this place I'll go for what? Empty set S3. So here I will write it S3. Empty set is here. Are you understanding this bitwise AND operation? Bitwise AND operation is implemented in where? Implemented in where? Set operation. If bitwise OR operation and AND operation are very much useful, students, in pandas. In data science also we will use. In NumPy, in many places we will use what? Bitwise AND operation we will use it. We don't use very frequently what operator? AND operator. AND operator I don't need at all, because I will prepare a beautiful explanation I will give you. I don't need AND operator. I will prepare shortcut process for AND operation I will explain. Shortcut process for AND operation I will explain. Shortcut process for AND operation I will tell you when I come to if else ternary operator is there or not. There I will explain. Are you following up to here? Bitwise or AND operator clear? Huh? Right. So I hope bitwise AND operator clear. Now, next operator is what? What is the next operator? Come on. Bitwise complement operator. So this I cannot complete now, because you will get most complicated. Students will feel complicated, people will feel, and it is not an NOT operator. It is not operator. What is this? You see, beginning only I will say. Beginning. Who is that student? One student said A is equal to 10. A is equal to some 1 or 2. Complement of A I will write. What is the answer is coming? Minus 1 or 3. Not A I will write it. Answer is coming what? False. Is it same? Bitwise complement operator is not a NOT operator. That ones must understand in the class. So this is a doubt of our students, and all these things are going to be called. I made it. I hope they realized it. So this I will stop it, and tomorrow class when I come back, I will explain what bitwise complement and bitwise XOR for 30 minutes first. First 30 minutes I will explain, and after that I'll go for what? Membership operators and identity operators I will explain. Membership operators, identity operators I will explain tomorrow. Don't miss the classes tomorrow. Okay, students? Tomorrow I'll go for what? Bitwise complement and XOR first 30 minutes. Next I'll go for other operators. Right? Thank you. All the best. Diagrams also I will upload, ma. Pooja. I will upload the diagrams also, ma. Don't worry about it. I'll upload diagrams also.